Advantech introduces the ADAM-6200 series Ethernet I/O modules with daisy chain in the training kit. For the agenda, we're going to talk about the introduction of the ADAM-6200 series, all the new features of the ADAM-6200 series, the utility configuration, digital I/O configuration, analog I/O configuration, Modbus polling and the ASCII commands, data streaming, peer-to-peer mode, GCL, the web server with HTML5, REST, and Java. First class is the introduction to the 6200 series. Why use remote I/O modules? Remote I/O modules will receive signals from the field I/O devices and sensors, and then transfer that information into a standard protocol using a serial or Ethernet interface to the controller. Sometimes we use wireless, such as the ADAM-2000 series down here. When you use remote I/O, remote I/O can be used in several ways to extend the distance of I/O and save money on wiring. Instead of running all the wires back to a home run rack-based system, you only have to run a serial or Ethernet cable, as shown here. When to use remote I/O? Remote I/O can be used to reject noise instead of having the long runs of cable, such as thermocouple cable, run all the way back to the central control room. You can use remote I/O modules deployed out in the field so that the communication interface coming back, the wiring will be basically Ethernet or serial or fiber optic, and this will eliminate noise rejection. What's new in the ADAM-6200 series? We have the daisy chain function, we have an auto bypass, group configuration, HTML5, and the Modbus TCP protocol with I/O LED indication. The family of the ADAM-6200 series will consist of 3 analog type modules, 3 digital I/O modules, and 2 relay modules. The analog input module, the ADAM-6200, will have 8 analog inputs. The thermocouple module will have 6 thermocouple inputs with CJC compensation. The ADAM-6224 will have 4 AOs and 4 DIs. The digital input and output modules will have the 6250 with 8 DIs, 7 DOs, and also have I/O LED indication. The 6251 will have 16 DIs with I/O LED indication, and the 6256 will have 16 channels of DO I/O LED indication. The 2 relay modules will have 6 channels of relay with I/O indication. The 6266 will have 4 relay channels and 4 digital inputs. Class 2 is the new features of the ADAM-6200 series. Daisy chain connectivity can save money on wiring, and also the number of switches you need. As you see here, we can also run up to 120 meters. We go from the switch to the first atom, from the first atom to the second atom, and so forth, instead of having to run home runs all the way back to the central switch. With the auto bypass protection, up to 2 modules can actually be powered off, or if there's any issues with the modules, Ethernet connectivity will still continue and pass through. So as long as you run each module within the 100-meter limitation, auto bypass will function just fine, instead of actually losing all of the field devices in a normal switch scenario. The auto bypass function is a built-in Ethernet switch to allow for daisy chain connection. The auto bypass provides a reliable Ethernet network because you can have 2 modules go offline and still have connectivity. It's important to note that the total connectivity must be shorter than 100 meters. So from the active module to the active module with 2 dead in the middle must not be more than 100 meters. The auto bypass mechanism has built-in relays that are powered on whenever the module is powered off. This can be supported for up to 4 days. It can support 2 modules in auto bypass. And after the module powers back online, it takes 2.5 seconds for the network to recover. We have the LED indicator for all the digital inputs and all the digital outputs. And also, with the locate function triggered by the utility, the status light will show for 30 seconds continuously. We have switches for the analog inputs that choose between voltage and current, and also on the digital inputs that choose between dry or wet contacts. With the 6200 series, we have bidirectional isolated wet contact inputs. In the older series, you needed a resistor to pull low. In the new ones, you do not. There is also a dip switch to choose whether or not it's a wet or dry contact. In essence, the 6200 series fully supports wet contacts without having to use the older circuit design. Class 3, utility configuration. The ADAM-6200 series utility operation basically is the same as the older 6000 series, where as long as you're on the same subnet, you can do a search and it'll populate all the modules listed below. The default password is 8 zeros, and the default IP is 10.0.0.1. The ADAM-6200 series has a couple new features, such as the DHCP support, and since you have DHCP support, you need a locate function, otherwise you can't find the module. For the ADAM-6200 series, the default password is 8 zeros, which can be changed, and also we have a reset factory default, which is something new. All the settings can be reset to the factory default, the calibration values, and the module configuration. We also have a system restart, so you can actually cycle power on the module without being near the module and having to do it physically. Using the utility, you can download the firmware, the web server files, such as the JavaScript or HTML, and you can also import and export configuration files. Security access control allows you to prevent unauthorized use of the module or access to the module. And you can set this by IP address or MAC address. So even if somebody knows the password, they still can get into the modules. Another new powerful feature by the ADAM-6200 series is for group configuration. You can send out system configuration, firmware, or HTML files to a group of modules all at one time. With the group configuration, you can right-click on Ethernet, select Group Configuration, choose whether you want the firmware, configuration, or HTML. Down here you choose which modules you want, or you click Select All, and then click Apply, and download all the modules. Class 4 is Digital I/O Configuration. Multiple digital input functions are supported, typical on-off, or counter input, and also frequency. Multiple functions supported on the digital outputs, typical on-off, pulse train, delayed pulse output with high polarity, or delayed pulse output with low polarity. The digital input and output modes can be chosen by selecting the module and then choosing whether you want what type of input you want or what type of output you want. There's also an option for choosing select all inputs or select all outputs. The digital input function has some advanced features for noise filtering and also counter values to keep the last value, and also you can invert the digital input. So a closed can be a 1 or a 0. Here is where you set the counter low signal width and high signal width. At the same time, you can also set noise canceling. This is very helpful when working with sensors for any kind of error rejection or false positives or false negatives. A very helpful feature. With the pulse output function, you can adjust the cycle You can also adjust the signal width for the low signal or the high signal width. Another important feature of the 6200 series is a communication watchdog. This allows you to set digital output values on a fail-safe value. You can choose to be on or off. You must enable the communication watchdog and then choose whether you want the digital input to be on or off when communication goes to an idle timeout and exceeds the idle timeout. Class 5, Analog I/O Configuration. For the analog input configuration, you can choose whether you want plus or minus 10 volts, 5 volts, 1 volt, or the different millivolts here. You can also choose current. With the current, we have burnout function also enabled. You can choose whether you want an upscale or downscale value. The analog inputs can be calibrated using an automatic calibration method. When you choose the module, you can select from the setup menu to allow calibration. This will enable you to use the auto calibration button here. When you click on this, it will allow you to automatically use the built-in circuitry to calibrate the module itself. The analog outputs can also be set with a startup value, or you can also change the slew rate for the analog value to be changed immediately, or by selecting a different slew rate. With the analog output, you can also set a fail-safe value. Choose safety, set the level you want, and then you also set the host idle time. And this will go to a fail-safe value. This is where you also choose startup or set the output. Another important feature of the 6200 series is the DI to AO safety value. You can choose whether you want this DI to trigger on a startup value or trigger on a safety value. Each DI is mapped to each AO. So DI1 goes to AO1. DI2 goes to AO2. And they also support a digital filter. We also support trending and data logging with the analog input modules. With the trending here, you can choose what channels you want, and you can select the polling interval. And you can also save the data to a file and choose where you want the data to be saved to in a CSV file format. Class 6, Modbus polling and ASCII command. With the ADAM-6200 series, the Modbus addresses can be assigned for each of the analog input channels and flags. You can set the start address for each of those individually, so not every module has to be the same. You can also look at the analog input status and get the error codes coming back. You can also reset the GCL counters in the ADAM-6200 series. This here is the ADAM-6200 default Modbus mapping table. For all the inputs and outputs, you use the 0x registers here. And for all the analogs, you use the 4x registers. With the utility, you can also choose the ADAM commander. You click here and select the device you want. Click connect, and then you can set parameters, or you can poll the device however you want to. There are many ASCII commands you can use with the ADAM-6200 series. When you use them, you'll see references such as $AAM. The AA should be replaced with a 01. This stands for Modbus ID 01. All the ADAM-6200 series are set to 01. Here's an example. He's sending a M at the end, which will return the module name, 6250. ADAM Commander, you can also choose ASCII. You can put in your command here and click send. You can also set UDP or TCP. When programming with the .NET class library, Advantech provides you with a complete list of all the sample codes that are out there. The ADAM-6200 series is a little different than the other modules because you can also change the Modbus tables. These samples are set up for the default settings in the Modbus tables. So if you change the Modbus configuration, these samples for the ADAM-6200 series will no longer function. Class 7, data streaming. There are three different types of data flow: polling and reply, periodically updating, or update triggered by an alarm or event. For the data streaming function, you specify the IPs that you want to stream to, the polling rate, and you click apply. You can monitor the data stream by using the utilities under Tools, Monitor Stream and Event Data, or you can use the sample code. Class 8, the peer-to-peer function. So why use peer-to-peer? With a master typical scenario, you have a polling and reply, and then you send out a message to another module, but you're using a controller for this function. With peer-to-peer, you can simply map a digital input to a digital output, or an analog in to an analog out, without having to use a controller. Another way of using the peer-to-peer is for extending a sensor wire over a long distance using Ethernet communication instead of having to use the native sensor wire type that you're using there, such as the thermocouple wire or something like that. You can just use the peer-to-peer function and transfer it over. There are two modes for the peer-to-peer function. There's a basic mode, which is one module to another module, so all channels input out to all channels to an output. The advanced mode allows you to have one channel go to one module or a second channel go to another module, etc. Peer-to-peer configuration is inside the utility. You choose either basic, advanced, or you can disable it. Select the source module to the destination IP address. The peer-to-peer configuration is done inside the utility. You can choose either basic or advanced or disable peer-to-peer. Another feature of the peer-to-peer functionality is you can, instead of sending the data periodically, you can also send it based on a change of state or a deviation. Here you choose the source module, IP, to the destination. Class 9, Graphical Control Logic, otherwise known as GCL. What is GCL? GCL is simple logic that can be run inside the I/O modules without having to use a PLC. GCL is a UDP protocol control. The graphical preset logic rules are set up from the utility. The logical rules are directly programmed in the I/O modules. There are four parts: the input, logic, execution, and output. The GCL is configured using the ADAM-APAX.NET utility. You select the module and then choose the module's name with the GCL at the end. Select Program, choose a rule, enable a rule, choose an input, select a logic, set the execution period, and then set the output. Here are the GCL steps outlined. GCL allows you to cascade up to 16 rules in each module. The reason you may want to cascade the rules is so you can have more than 3 inputs examined for one output. The inputs and outputs for the GCL can be, as shown here, counter frequency, auxiliary flags, DOs, or the outputs you can have counter, pulse, timer, or auxiliary flags. You can also send a message. The GCL outputs can be local or remote. One module can have 16 logical rules. To define the remote outputs, you first select the IP table and select the modules that you want to talk to. Then you choose the destination module over here and select the operation, and then you choose the output. With a GCL, you can import and export the projects by clicking here. This will open up the project content. You can save or open content, and it will list the rules down here. So as a summary, the GCL allows you to have no controller, no additional software. It's a simple utility. It's secured by IP or MAC address. You can monitor the GCL. One module includes 16 rules, and the rules can be cascaded and can be expanded over other modules. Class 10, the web server. The ADAM-6200s support remote monitoring control with portable devices. Programmed using HTML5, you can support the latest web browsers on smart devices, such as the iPhone and iPad. You can access the modules via Ethernet to monitor and control the I/O in the application in the field. The benefit is you can directly monitor the 6200 in the field without the use of a SCADA or need of a SCADA. Before, with the built-in web servers, you had to use HTML plus a Java runtime. And Java runtimes can be complicated to maintain. Now we support HTML and REST. You can use the get and post syntax. We'll talk about that later. You can also use HTML and Java with no runtime needed, or HTML and JavaScript. The ADAM-6200 supports REST. We currently support the get and post syntax. These are examples of using scripting in HTML5, or you can simply type in a URL to get the values or set the values. There are several ways to access the web server. You can enter the IP of the ADAM module itself. You can open up the utility and then click on the QR code, which will open up a web browser, as shown here. Or you can scan the QR code in the utility to your phone. The default account is root. The default password is 8 zeros. So in summary, programming with the web server supports HTML5, REST, Java for accessing the ADAM, and JavaScript programming. You can download the HTML files and the JavaScript using utilities.